Hello and welcome OnStep fans or fans of the telescope controller OnStep from Howard Dutton. This is the homepage of OnStep and the wiki from OnStep, but this episode is not about OnStep but on the Smart Hand Controller for OnStep. Unfortunately, I had to re-audio everything, but okay. The OnStep Hand Controller is a very nifty tool and enables you to control your OnStep controller with Wi-Fi or with a cable, but I'm only interested in the Wi-Fi version here. Normally this is done via buttons, as you can see, but there's also a joystick option. And what I thought is there's a lot of standard hardware out there. I didn't want to solder a PCB, get all these parts you can see here. There's an OLED, there are buttons, there is a turn on, turn off button. Isn't there a possibility to do this via standard hardware and not getting a PCB from China? On the right side, you see the hand controller user manual and the hand controller page, which is shown here, which options you have, and yes, much resources about this controller hardware. So, as of the OnStep controller, there exist, meanwhile, some 3D printer and engraver hardware code samples, so you can directly load onto an engraver board, like here, shown the MKS Gen L board. Sorry for the picture isn't sharp. You load it, you put drivers onto it, you configure it, and then you're almost ready to go, and you almost have a running OnStep controller. That's what I did in the past. I did it for several mounts, and it's working fine. But what I never got was such a smart hand controller. I did everything via the app or via external software. That's why I posted at the OnStep groups, IO messages or chat, this question: while a smart hand controller with a standard ESP32 board and a standard joystick shield. Because a joystick shield, in my opinion, everything has on it which you need. It's a joystick, it has buttons, and a standard breakout board for an ESP32 controller also has everything you need to get running without soldering, without welding, just putting a few cables together and these two standard parts, putting a 3D enclosure, and yes, you should be ready to go. So this thread is now about reaching 18 posts, and thanks to the hard work of Howard and me, we got it going, and this is the solution, the rapid bulky wSHC, the wireless smart hand controller. I created a GitHub page where everything is posted, the actual Fusion 3D files and also the STLs files, to put them on the controller, the configuration for the Smart Hand Controller software, some media, a platform I/O INI, if you like to program not with Arduino but platform I/O, and many other useful informations how to get running. This is a very early prototype. It's looking much better now. But mainly there is on the left side, upper left side, the joystick shield, and in the bottom of the case there is a, as you can see on the right upper picture, on the right side down, there is a breakout board with an ESP32 controller. The purpose of this project is to build a smart hand controller with a button or joystick shield. Probably there will be some versions in the future. I want to build a wireless smart hand controller, not connected with a cable. I want to build it fast and with it cheap. I don't want to get anything from China. I want to just go to Amazon or eBay, and after 2 days I want to have the parts in my post office. I don't want to do welding, and I don't want to order a PCB. A battery is not included, and I don't think it's necessary, because if you disconnect the smart hand controller, it's no problem. It doesn't affect anything. Just reconnect it and it's working again within seconds. So that's why I decided to go with an external battery pack. Okay. Let's just wait for the next screen. So costs. Okay. We have a total cost per unit. If you are really in a hurry, and you won't get the parts very cheap. So you have to count, and if you have a battery and cables also, you have to be, you will reach about 15 to 20 euro or dollar respectively. If you get everything from a China seller and you get more parts than just one, e.g. for a classroom project, you will be way under $10. Not a battery included. If you need additional cables, additional battery packs, additional crimp tool set, for example, you will be 30 plus. A crimp tool set alone is $30 or $20. Depends what you get and which quality you get and where you get it. But the best thing is everything you buy here is not wasted, because you can reuse it. Nothing is welded. So on this page I show mainly everything which is needed, and we should skip it, the content, and go for it. So now that we talked about the resources on GitHub /apos, that's my repository, and the OnStep resources, the OnStep chat, we should go for the ESP32 form factors. That's what I like to talk about. Afterwards, we are talking about the reference design, then we are talking about the 3D model, and then how to build it. Let's talk about these little guys. These are ESP32 controllers, as you can see, in 4 different form factors. On the left side, this is the most common one, I think. It's a 30-pin model, and it has on the upper side it has the ESP VROM with wireless. It has an USB-C jack, which I like very much because I don't have to bother around. It has on the left side it has two buttons. On the left side it has a boot button. On the right side it has the download button, which you need if you like to program the ESP32. You have to press it, and then the source code will be loaded up and the ESP32 will be programmed. Then the next model is has a little bit different pin layout. It has 38 pins, so 19 pins of each side, and it also is a little bit narrower. It also has an USB-C type jack, connector jack, and from the functionality they are almost the same. Probably it has Bluetooth. The next one has a different layout too, and it's narrower too. It's like the second one, and it also has not just a different pin layout, it also has Bluetooth, as far as I remember, and it has what I'm talking about here. Okay, it has just a reset button, not a download button. I don't know how this works in practice, but normally the chip which is on here, the UART chip, should be handle this when you press upload or program in your Arduino IDE. So what's special on this one is this kind of jack. This is, you can put a standard lithium accumulator on it, and it's charged over the USB port here, in USB micro port, with 500 milliamps, if I remember right. And that's very handy, and probably I will use this design in the future to include a lithium-ion battery pack. On the right side, this was my first model I got. And I'll show in a few seconds why I did this. This is an Arduino form factor. It basically is working. And the idea was to combine these two. On the left side, this is an Arduino shield. It's very compact, it's very slim, and that's why I bought it. Within a few days, I encountered that last year I got almost, it's not produced anymore, so that's a problem. What should I say? It has 6 buttons, it has some pins on the right side, but I cut them off, as you can see. So there's very little overhead, and there's a voltage selector from 3.3 to 5 volt. I run it on 3.3 volts. So the idea was to simply stack these together. You can see here on the right side a nice voltage connector. So just put it together, put the Smart Hand Controller on it, put the power jack in, put an OLED on, and you're ready to go. That was the idea. But as you can see, first, you cannot connect the OLED because there are no pins where you can connect them. That's the first thing. And the second thing is the pin layout of the shield leads to a pin connected to the ESP, which is A2 and A4. here, co-spanning. So the problem is if you're using Wi-Fi on the ESP32, you simply cannot use these two pins. There are other pins. There are the pins 36, 7, 8, and 9 above the A2 and A4. But this is not the standard layout that Howard's code for the Smart Hand Controller uses. So I want to go with the standard. I don't want to solder. And there had been other problems. The board did not boot, and so on and so forth. I spent a whole Sunday getting this thing run, but I abandoned it completely because it simply does not work. And also, I think this form factor in combination with an ESP32 has no future. Really, why should you put an ESP32 on an Arduino form factor? These are two completely different hardware forms and pin layouts, so it simply makes no sense. So I abandon this right one. Yes, that's it. It's working, but just put it away. Instead, we are using these, and especially the two left ones, in combination with a breakout board. We can use a breakout board with clamps, like this one. I didn't test the right one, but I think it should probably, despite it has a few more connectors with this board, because that's interesting, and these clamps make it very robust when it comes to get clean connections or make prototyping. I like this very much. And I also made the design so you can use this breakout board in combination with the shield you saw in the moment. Again, the right one does not exactly match, but it's from the width. You can put it on this board, but it has a few more pins. So that's the first solution. And the second solution is this breakout board. As you can see, you just will stick it on top. The ESP, this is this 30 pin. Right, it's the 38 pin, and this is the 30 pin. It's a little bit wider. Its width is another. So, and neat is it has USB-C, and it also has a round connector, DC connector jack, and you can put 6.5 to 16 volts on it, and it it delivers you 3.3 volts and 3.5 volts on these connectors, and the yellow switch or the yellows with a yellow jumper, you can select the voltage you like. I use only 3.3 volts on this board. So both boards, breakout boards, are a good way to go for prototyping. That's the reference design I will use. As you can see, you cannot simply stack them together. You have to put cables between these two, but that's intended. You also need space for the OLED, so that's no problem at all. What else is to say? Yeah, okay. Probably in future I will use such a joystick in combination with some buttons. You can then take a solder board to solder the buttons onto it and combine it with such a joystick, and you're ready to go for a very simple design. So now we talked about the ESP32 form factors, and let's go to the reference design concerning the hardware and the pin maps. We talked about that. When we're talking about the reference design, it's very simple. On the left, you should draw yourself a little diagram like this. On the left side is the ESP. On the right side is the joystick board, and you have to know which connectors you have to put on which side. On the bottom you see the voltage, and here I'm showing the voltage regulator. Everything is on 3.3 volts. Some joystick boards, especially for Raspberry Pi, require 5 volts. So then we stack the Breakout board and the ESP together. We check that the 3.3 volt selector is used, and then we just have to know which buttons and which pins of the ESP we have or we should connect. You get this from the pin map file. This is in the source code from the wSHC controller, and I think it's called pin ESP32H, but I don't remember it exactly, but I think this is the file you should look for, which pins to connect. So what else? Okay. If I remember right, or what I have to say, these pins of the joystick board, for X and Y, these are analog pins. And analog pins means, and the other ones, F, X, and are digital pins. What does it mean? X is the main button for the menu, and F are the feature buttons, which when you select an item, they just toggle the value. That's how it intended to work, and you can read it on the controller manual. On the right side, you see how the joystick works. The joystick mainly has 2 potentiometers, and one for X and one for Y. And the middle position is really the middle position of the potentiometer. So if you push the potentiometer on both potentiometers on their corresponding minimum value, which is on the left upper side, it has no resistance. And if you're going to push them on the maximum position, which is corresponding on the right down side, lower side, then it's on the maximum. And this corresponds to a signal which is sent to the ESP32 and calculated to the software from the Smart Hand Controller. everything you can fine granular let's say configure within the config H file, and I put a configuration sample within the GitHub page. And you can also read it on the OnStep thread I mentioned before. You can, for example, switch north-south and east-west direction and other things. So that's the hardware. As you can see, I made and I crimped my cables by myself, so I got the correct length. On the right side we have the shield, and then we have the OLED. What else do you need? I recommend some glasses so you can correctly read the pins if you have some problems with your eyes. You can use these standard cables, and you can. You should also you need some fast glue, and you should put the fast glue on these kind of tips. Then I recommend to use some double-sided tapes, soft double-sided tape, which is needed to fixate the breakout board within the 3D printed housing. In future versions I will fix this. So what else do you need is an accumulator pack. It doesn't matter which one, and corresponding USB-C or USB, micro USB cable or whatever you need for your special configuration. As I said, in a moment it's not intended to work with the battery pack. Then the OLED I use here as a 1.3 inch. It has 4 connectors on the it's written down on the left side. I think this is ground. Then there comes wSHC, SDA and SCL, or SCL and SCA. See this later. Okay. The only thing you have to know how the pins on the right side of the joystick shield match with the pins on the left side of your prototyping board. Yes, that's all we need to know. I like these connectors very much, and instead of using just single pin ones, because these 2 or 3 or 4 pins are a little bit more stable or robust when it comes to connect to your hardware. I used this crimping tool from Amazon, which I found is very good, and it costed me about, I think, 30 euro or something like that. So, and it comes with such a box with different type of Dupont connectors and sizes. So you can put more than one cable together, and this makes it more easy to assemble everything. That's my personal opinion. And there will be no problem when connecting everything together. So, but you can also use these standard cables. Normally, these cables are 20 centimeters or 10 centimeters long. For the housing here, you can use 10 centimeters. So that's about reference design. Now let's switch to the 3D model. I'm doing the 3D model with Fusion 360. And I show to you how to assemble the parts. When it comes to the parts, I recommend using good quality printing material. I recommend using PLA, and I recommend to print it 0.2 millimeter quality. On the right downside, you see some optional parts. There are some screws which you can use to really sturdy screw everything together. So this is not necessary. Let's see how the size is. I think it's 33 millimeter long, M3, not inch, M3, and it's inch. It's 0.9 inch long. They will be screwed into the bottom house. Therefore, you need to print this with support. Into the bottom house, there comes or gets the breakout board. You can use both boards. When you use the bigger one, it's a little bit tricky, but you see, you could just press it down and then it firmly sits into the house. In the newer design files, which are uploaded today, this is a little bit more easy to handle. At the bottom, there are pins for the Arduino form factor. In the newer design, I removed them, and instead I deliver these inlets, and these inlets have the corresponding pins for the needed for the breakout board you're using. So I think this is a little bit more future-proof than print the pins onto the base itself. Next, we have a middle plane, and this middle plane is for the shield, and it nicely fits through some holes to the bottom. When we are talking about the base, we also have two holes. I think I'm showing them now. I hope I do. Let's wait a little bit. Yes, there we go. And these holes you have to drill through, or just and take a screwdriver and put some screws, no problem. So they are for straps. So you can easily put them in and therefore can hang this thing onto your mount if you don't like to print out the holder. Then there is a front plate. I have two ones. I have one for the connectors and one which is. And then there are two holes on the bottom. And these two holes can be. That's not very good here. I have to design something else. Put them in when the screws are screwed inside. So, as I said, everything is very tight. And then the OLED screen is here. And then this is the top. And then there's a little part, you have to glue this together, and that hinders parts to fall in. Yeah, it looks also a little bit better. As I said, just use glue. And then there's a cap for this OLED housing, which also needs to be glued together. So let's put the parts into it. Use some of the double-sided tape I showed you in the beginning. This will fixate this a little bit. And then we take the middle plate onto it. This is the cable for the OLED. This is the cable for the buttons, the 3 buttons, X, major and minor F. And this on the right side is for 3.3 volts for the joystick board. Let's zoom a little bit in. And the other one is for the X and Y. So that's very easy. Now we can put things together, or depends on what you like. I myself, I prefer to first press the things together. Please be gently when pushing them down, especially the middle one. There are holes. There are holes, and on the back there's a big one. So this is very tight and doesn't need any screwing if you're just in a prototyping phase. But if you're going into the field, I recommend using the screws. So then we can use or take the shield, X and Y. Should be the right directions. As I can tell you, this was the default direction, but okay. And also the power here, don't screw it up, or your board is not working. It makes no harm to the processor, but it's simply not working. So take care of the cables. And there are 4 snaps for the Arduino form factor board here, and in future there will be for the other shields, and this should snap in without any glue and without double-sided tape. But I did not do this in the button. Be aware of the voltage regulator, as I showed a few seconds ago, that it is on 3.3, as I showed. And there you have the corresponding pins for 5 volt and 3.3. Don't mix that up, because if you do, things won't work. So this is the connector for the OLED. On the left side there's ground, then there comes 3.3 volt, or these type of things also run with 5 volts, but okay. Let's see if we can get this sharp. No, sorry, but this is ground, VCC, SCL, SCD. And I also put it in here, A, C, this should be plus or something like that, and then ground. when you push it in, do it gently. First put the side with the connectors in, and then the other one. If it's not going and not working, don't force it. You will break the OLED. Just take a screwdriver, push the thing here outwards, the plastic part outwards, and then it steps slightly in the housing. Really, don't use too much force. It should snap into it very seamlessly. So now we're ready to connect the parts. As you can see, there are some holes here, and there are some parts here which slide under the middle plane, you see. So put it in, and then you need really a little bit of force to push everything together. It's not that easy, but when it makes cluck, it's very tight, and you see this really fits, and it really is good designed. So just check. Now, before we go further, we just should check if everything is connected right. So power seems to be okay. And then we toggle normally on, if you go on the right side, you should select. And there you see, oh, this is not, this north and south and east and west are not corrected right. So this is, I have to disconnect and just change the Y and the X connector, but this is really no problem. Just turn it around, the yellow and the white one here, just turn it around and it should go. Double check your, you see, I made it a little bit too short, the connector for the power. So put everything together again. Wait a little bit. It's starting. Now you get the selection for the Smart Hand Controller. Okay, now we can connect to our OnStep. I have an OnStep running in the moment. If you don't have an OnStep running, you won't get connected. Sometimes to get these restart, but that's no problem. Connection okay. So there we go. These three buttons tested. The X button works. Long press goes to the menu, and the short press, you saw it, just toggles the menu. So I put everything together, and I highly recommend to first glue these parts together before you assemble everything. And therefore you take the fast glue and put it onto these tips. So, and then we can nicely put the glue inside of this tiny little face here. This is very exactly so it's matches this part. Don't force it. It's just slides in and makes click and should go into it. You see? So that's it. And now a little trick. If you this glue works with the humidity, with water, yeah, of the air. So if you take your mouth and then apply a little bit humidity to moisture is the right word in English, moisture, to the glue. It immediately will work. This is the same as you would use activator. So when you slide this in, you see this direction. This is also constructed to hold together. That's it now. I don't apply the back now. The back has two parts. It's a thinner one and a little bit thicker one. The thinner one is on the upper side and the thicker one is on the bottom. You have to glue it by yourself. I know it's not a masterpiece. It depends on how your printer is working, but it's okay for this kind of thing. Probably I'm doing another hardware example in the future, or if you like, you can alter it by yourself. Then you can put the front onto it, but as I can see now, and in the video I already altered it, I forgot something when I designed it. On the left side, it's too big, but it's working in the actual model. So just look how I try it with force, but it's not working. So leave it for now. That's it. That's almost everything we have to do. Getting very rapidly, I think, if you know how to do, within, I think, 20 minutes for a classroom project, if printer parts are prepared and everything hardware is there, a smart hand controller running. And I think it's already also good to go. Oh, there's a misconnection. We have to see. No, it's okay. So it's connected. I just try. No, it's okay. Everything is robust. So just wanted to test. If you like to screw everything, just show you. It's very simple. You put the screw in. I just show it with one screw. Goes in and it fits into the upper part, and the upper part presses everything, every other part together. So within a few seconds you see now everything is, don't push it too much. So this is very sturdy and nothing happens. This will not break and this will not fall apart. That's it for now. Have fun, a lot of fun with this Smart Hand Controller project. As I said, in the future I will do another design for more common joystick shields. The problem is that this joystick shield, as much as complex it is. And there I'm going to make a design for the big 2.4 OLED, but Howard has to implement the software because this is E2C, E2C OLED. But okay, I'm implementing also other joystick shields. So this design is not sold anymore. You cannot get it. As far as I know, I saw some for 10 euro or so, but that's a lot. And it should be no problem to integrate others, as long as like these ones. These are about 1 or 2 or 3 euros from AliExpress, and these are the most common ones. The problem is that they have a lot of connectors at the top, and that's why I didn't choose them in the first place. But I think this is the one I bought, but I only found 2 or 3 sellers, and they are very, very expensive. They're about 10 euro without shipping. So probably this is not a good choice. If you if you're looking here, these connectors, I hope I can cut them off, so there won't be a problem. But we will see. We will see. Okay, that's it for now. I hope you will have a lot of fun with the Smart Hand Controller, and especially, no, that's the wrong page, especially with the rapid, bulky wSHC wireless Smart Hand Controller I designed, and as far as I can say, it made a much fun. I thank Howard a lot, and I wish you the very best.